So let's talk about one of the most powerful trends happening in AI right now, LLM fine-tuning. It's really the secret sauce that lets just about anyone create a highly specialized AI, but without the absolutely massive cost of starting from scratch. We're going to break down exactly how it works. Okay, so you want an AI that really gets you, that understands your industry's specific jargon or your company's unique voice. The problem? Well, building a large language model from the ground up takes a staggering amount of data, weeks, if not months, of training on supercomputers and, a huge budget. It's a massive roadblock for most people. But what if there was a shortcut? And that shortcut is fine-tuning. Honestly, the best way to wrap your head around it is with this on-the-job training analogy. So imagine you hire an absolute genius who already has this vast general knowledge about the world. You don't need to teach them to read or write, right? Fine-tuning is like giving that genius your internal company documents and just letting them shadow your top employees. They keep all their broad knowledge, but they very quickly become an expert in your specific world. So here's what we're going to cover. First, we'll talk about why fine-tuning is such a game-changing shortcut. Then we'll look at the two main ways to do it, kind of the heavyweight versus the lightweight approach. We'll walk through a 6-step guide on how it's actually done, cover 3 big challenges to watch out for, and then we'll wrap up by looking at what's next for custom AI. All right, first up, the fine-tuning shortcut. The whole idea here is simple, it's powerful, and it all boils down to just one word: efficiency. The real magic here, and this is what you need to remember, is the incredible scale of that efficiency. Think about it. Instead of needing millions of data points to build a model from the ground up, you can create a specialist AI with just a few thousand targeted examples. Things like your past customer support tickets or a bunch of legal contracts. This just slashes the time, the cost, and the data you need by orders of magnitude. It's a huge deal. So how do you actually go about this? Well, broadly speaking, there are 2 main paths you can take to specialize your model. Let's break them down. The first path is what's called full fine-tuning. This is the heavyweight champ. You take your new specialized data and you use it to adjust every single parameter in that pre-trained model. You're essentially retraining its entire brain. This gives you the potential for the absolute highest performance, but it's the V8 engine of AI. It's going to give you maximum power, but it eats up a massive amount of computational resources and memory. Now, the second path, and this one is becoming incredibly popular, is parameter efficient fine-tuning, or PEFT for short. Think of this as the super efficient hybrid engine. Instead of changing everything, you freeze most of the original model's brain and only train a very small number of new parts. We're talking often less than 1% of the total. And the result? You get performance that's almost just as good, but with a tiny fraction of the cost. So here's how they stack up side by side. Full fine-tuning can give you that top-tier performance, but it comes with a high price tag and a bigger risk of something called catastrophic forgetting. That's where the model gets so specialized it actually forgets some of its original general smarts. On the other hand, PEFT gets you near top performance for a really low cost. And because the original model is mostly left alone, there's a much, much lower risk of it forgetting what it already knows. And inside the world of PFT, there are a couple of techniques you see everywhere right now. First is LoRA, which stands for low rank adaptation. It's clever. It just adds these small new trainable modules into each layer of the model, so you only have to train those tiny new bits. And then there's QLoRA, which is even more amazing. First, it shrinks the whole model down to a super lightweight format, and then it applies LoRA. This is a total game changer because it makes it possible to fine-tune these massive models on a single GPU you could buy off the shelf. Okay, you get the different approaches. Now, let's get practical. Here's a 6-step guide that takes you all the way from just an idea to a fully deployed custom AI model. The whole process really breaks down into these 6 key stages. It all starts with step 1. You've got to define your task and pick the right base model. What do you want it to do? Summarize text? Write code? Then step 2 is to prepare your data set. And look, this is probably the most critical part. Your model's only as good as the data you feed it. Step 3, you configure the training. You're twisting all the important knobs, like learning rate. After that, step 4 is showtime. You actually execute the fine-tuning. But you're not done. Step 5, you have to rigorously evaluate the model. Does it actually work on stuff it's never seen before? And finally, step 6, you deploy your custom AI out into the real world and keep an eye on how it's doing. Now, as powerful as fine-tuning is, it is not a magic bullet. There are definitely some pitfalls. So let's look at 3 common challenges you really need to be aware of. The first big one is overfitting. This is what happens when your model learns your training data too well. It basically memorizes the answers, and then it just falls apart when it sees new data. It's related to that catastrophic forgetting we talked about, where your legal expert AI suddenly can't handle a simple conversation. The solution is to be gentle. Use a really low learning rate and stop the training process early, right at that sweet spot where performance peaks. Next up, a very real-world problem: cost. Even with fine-tuning, training these huge models can require some seriously expensive hardware. We're talking high-end GPUs with tons of memory. And this brings us right back to why methods like PEFT and LoRA are so important. They're not just some cool academic ideas. They are the key that makes custom AI accessible to everyone, not just companies with a supercomputer in the basement. And a final critical challenge is bias. The model can and will learn and even amplify any biases that are hiding in your training data. This is a huge deal. If your data is biased, your AI will be biased. The only way to fight this is to meticulously review and clean your dataset, and then constantly test your model's outputs to make sure they're fair and balanced. So that's where fine-tuning is today. But this field is moving at lightning speed. So let's wrap up by looking ahead at what's just around the corner. The future here is incredibly exciting. We're going to see more automation, with AI systems literally helping us find the best way to fine-tune other AIs. We're moving fast toward multimodality, which means fine-tuning models that get text, images, and audio all at once. Of course, efficiency will just keep getting better, making this even cheaper and faster. And maybe most importantly, new privacy techniques are coming that will let us train on sensitive data without ever having to expose it. Ultimately, fine-tuning is the bridge. It connects general, all-purpose AI to the specific, valuable knowledge that makes your work, your company, your project unique. It's the tool that lets you build AI solutions that are truly smart and truly relevant. So the question really isn't if you can build a custom AI anymore. The question is, what are you going to teach it?